Okay, so having discussed legendless polynomial and a few things one sort of confusing result, not confusing as such, but we were trying to do something called as point dipole in the previous lecture. Today we are going to start in electrostatics a topic called as multipole expansion. So whoever sees a recorded version to the same, kindly refer to the legendless polynomial. In the separate section, I have taught that, and only then you can proceed with this kind of lecture. But if you have done it and if you're regular right now, so let us start with the multipole expansion. Okay, so multipole expansion. Am I audible now? कोई दिक्कत तो नहीं?
Yes, sir.
Okay, so this is multipole expansions, and we've done quite a bit of all these things in our lectures on legendless polynomial, and a little bit also we'll do later on. But mostly this multipole expansion. So let us begin with what Griffith has to say, and I'll take that reference only. So as such, Griffith also, and in general also with regards to exam also, we want, what is our initial thought? What is our initial thought is that if a generalized charged configuration is given to us, so let's say this is a generalized charge configuration. We don't know how the charges are distributed, but just we know that this is a generalized, or you can say localized, generalized charge distribution given to us, localized at some region R, or let's say whatever. So let's say there is some region R where this generalized local charge distribution is localized. Okay, localized in some region, let's say R. And what we want to find that how would potentials look like? How would potentials look like at a very far away distance? That is, we want to find an approximate. We want to find an approximate. We want to take an approximate idea of how I should say potentials behave at a very large distance. Of how potentials behave at large distance. At large distances, or we can say that we want to find what is an asymptotic variations. How does your what are asymptotic asymptotic variation of potential due to this sort of generalized distribution. So what I will do, I will simply take a small scoop of volume from here. So I'll just take a small scoop of volume. Okay. So till now we were doing if people have attended the class in the legendless polynomial, we were taking some nice arrangements which we are quite aware also from. So these are kind of nice arrangement. This is linear octopole, and then we were discussing linear quadrupole and linear dipole. So all these arrangements are quite clear to us. Now we are taking all the more a very generalized problem, a very generalized problem in the sense that we don't know how the charges are distributed within the volume. All we know that okay, that there is a generalized distribution of charge. It may be plus, minus, all sort of possible things are there, and we'll just in order to take this kind of in order to consider this kind of problem, we'll just take a small scoop of volume. So I'll take just a small scoop of volume. This small scoop of volume I've taken is let's say d tau, and we'll use the unprimed coordinates. So we'll use the primed coordinates for the volume inside, and for outside we'll use unprimed coordinates. Okay. So let's say if you've taken origin somewhere, and from there we have taken this small scoop of volume, and let's say this is your r vector dash. Okay, and let us say this is at some point P, and this is, let's say, your origin, which is at a distance smaller. Okay, we want to find potential due to this entire charge distribution. Okay, so what we'll do, we'll distribute this charge distribution into small d tau dash, and this charge, whatever the charge, let's say dq dash, we want to find potential due to this. So this distance would indeed be, and let's say this angle, let us say it's theta dash. So I told you whatever lies inside the volume, I'll take prime coordinates for it, and whatever lies outside this volume, I'll take unprime coordinates for it. So what it would be r square, and then I'll write r dash ka square, and I'll write minus 2r dash, and I'll write cos theta dash ka root over. Is that clear? I mean, this distance, I hope it is clear. So now, because of this charge dq dash, the potential at point P would be equivalent to writing, let's say this is at r vector. So I'll write potential at r vector can be written as I should write k integration dq dash divided by distance. This distance is given by root over, I'll write r square, and then I'll write r dash ka square, and then I will write minus 2 r dash, and then I will write cos theta dash. Is that clear? I think this is quite clear to you. Is that clear? And so I'll write my potential as a function at some distance r vector from the origin as in, I will write it as, I think, k. This is k, and then integration dq dash की जगह काम करो, just write rho r dash, and let's say the volume charge density of this is rho. This will be rho r dash, and this will be d tau dash. Is that clear? So the volume is given by d tau dash, charge enclosed is dq dash, and let's say if in this region R the volume charge density is uniformly distributed given by rho, then I can replace this by rho r dash d tau dash divided by, you just take r common out. So if I just take r common out, I'll get root over 1 plus r dash upon r ka whole square, and then I will get minus 2 r dash upon r, and then I will get cos theta dash. Is that clear? ये चीज समझ में आ गई यहाँ तक? I don't think यहाँ तक किसी को भी इशू होना चाहिए. And what I will write, I can simply write that my vr dash is nothing but it is equals to integration k rho, अब इस k को बाहर ही कर देते हैं, 1/4 pi epsilon naught लिख दो बाहर, and this will be rho r dash, and there would be d tau dash, and there would be 1 over r also written here. So I have written 1 over r, and what this would be equivalent to writing summation r dash upon r की whole power n, and then I will write pn cos theta dash. यहाँ तक किसी को दिक्कत? कहाँ गए सारे के सारे? कल्पना समझ में आया यहाँ तक कि नहीं? ठीक है. So
Yes.
this is how you see handy your generating function is. So this is via generating functions of the Legend's polynomial you could write in this fashion. Is that clear?
Yes, sir.
Okay, so this is how handy your this thing is, right? So in any case, if I want to write it in more decent fashion, this r, because this integration is going on unprimed, so this integration is going on prime coordinates, so you can take unprimed coordinates completely outside. So I've written v as a function of r can be written as 1 over 4 pi epsilon naught, and I will write simply r raised to power n plus 1. Okay. नहीं, एक काम करते हैं, n है ना यहाँ पे, तो इसको तो सम में तो लेना ही पड़ेगा. So I'll write sums n equal to 0 to infinity. I'll write 1 upon r की power n plus 1, and then I will write integration, because this you can take outside integration because this is not much of worry. And what does it mean? एक बार तुम r dash की power 0 लोगे, फिर p not p not cos theta dash और rho r dash d tau dash इंटीग्रेट करोगे, प्लस फिर तुम क्या करोगे, n की जगह 1 लोगे, r dash pn cos p1 cos theta dash rho r dash d tau dash, फिर वो ऐसे कर करके सारे लिखोगे. So instead of that, I have taken summation common out बाहर की तरफ ले लिया, and this will be equivalent to writing r dash, and here I'll write simply n, and I'll write pn cos theta dash, and then I will write कहाँ गया एक और term, rho r dash होना चाहिए term, and then there would be a term d tau dash. Is that clear? So this is how you can express your potential. This is how you can express your potential. Is that clear? ये समझ में आया नहीं है? थोड़ा ध्यान से देखो.
Yes, sir.
ठीक है? Is that clear? आया ना तो बोलो, आंसर देके साइन सर.
Yes, sir. Yes.
ओके. सो इसका मतलब क्या है? ओके. Okay. So what we have done now, if you take n equal to 0, so if you take, I'll write more explicitly in this sense कि इसको ढंग से लिखे तो भी r vector will be, I think, 1 upon 4 pi epsilon naught. एक बार n की जगह 1 लो, so it will be integral. Simply, I think this would be 1 over r, so I'll write 1 over r, and then there would be rho r dash and simply d dash, right? Because this n equal to 1 means 0, r dash की power 0 is 1, and p naught is again plus 1 upon 4 pi epsilon naught, and then I will write r square in this particular term, the second term would be, I think this would be r dash, and then I'll write cos theta dash, and then I will write rho r dash, and then I will write d tau dash. Is that clear, this term? Then again, there would be a term 1 upon 4 pi epsilon naught r cube, and then there would be integration r dash ka whole square 3 upon 2 cos square theta dash minus 1 upon 2, and there would be rho r dash. All these things will come up. So what is happening? The potential can be written as sum of all these contribution. If you closely see this, this is something what you called as kq upon r. So this rho r dash d tau dash will give you q. This is kq upon r. So this is your contribution from your monopoles. So whatever monopole sort of arrangement would be there in this kind of volume in general. Okay, so this will give you this. Then there's a possibility that the charges are equal in opposites and in some sort of thing. So this second term, we'll expand it later on. This is a contribution from dipole. And also here you can see this particular term. Lately we'll see that this quadrupole moment, when I'll teach you, will come out to be tensor. But right now, just understand that this term is due to the quadrupoles, possible quadrupoles in this arrangement. So this is the beauty of mathematics. We don't know what is the exact arrangement within. We don't know how the charges are, what should I say, placed. Okay, I don't know what sort of distances the dipoles are placed. In general, mathematics has given us a very nice result, that it has given us the potential in this form, and expressing potential in this sort of form is referred to as multipole expansion. This is referred to as multipole expansion. Is that clear? Or is that not clear?
Clear there.
Okay. Okay, so in any case, you can see that your potential is proportional to 1 over r cube here for quadrupole. Potential for dipole is proportional to 1 over r square here, because this will be some, like whenever the integration limits are introduced, this will become some constant. So overall, you can understand this particular sort of expansion is referred to as what you know as your multipole expansion. Is that clear to you? ओके, इज दैट क्लियर टू यू? ये चीज तो समझ में आएगी। चलो अब इसका आगे बढ़ते हैं। ओके, सेकंड, थोड़ा सा अगर ध्यान से देखें, जिस पे आज कॉन्सेंट्रेट करते हैं, लेट अस टेक first for instance, just take the dipole term, because mostly in exam also, otherwise also, this dipole is an important thing. So you know the first term is clearly your it is clearly kq upon r only. ये चीज तो क्या है? This is q only, like rho r dash g tau dash होगा, total charge q बता देगा. This is 1 upon 4 pi epsilon naught is simply k, and this is simply r. So this is sort of monopole contribution only ना. So इस पे तो ज्यादा सोचने की जरूरत नहीं है. So इस पे सोचो, the second term is 1 upon 4 pi epsilon naught r square, and then you have integral what it was, I think it was r dash cos theta dash, and then you had this rho r dash, and again I'll write इसको वेक्टर बना दिया, ठीक है? Is that clear? ये चीज समझ में आई? And let us थोड़ा सा ध्यान से देखो इस चीज को, कहाँ पे गया ये हमारा, इस कोऑर्डिनेट से इसको ला सकता हूँ क्या मैं किसी तरीके से? लेट मी सी, अगर ये किसी तरीके से आ जाए तो बहुत ही बढ़िया होगा हमारे लिए। ओके, लेट अस सी, अगर आ गया तो मजे आ जाएंगे, ठीक है? सो लेट अस कॉपी इट, इधर इधर ले आते हैं, ठीक है? थोड़ा ध्यान से देखेंगे इसको यहाँ पे। Okay, so this is what our arrangement was, right? So this is how our arrangement was. So किसी ने भी जिसने भी कॉपी और पेस्ट का कमांड बनाया है उसको मतलब भगवान उसका भला करे पहुंचाता, ठीक है? ठीक है, सो दिस इज व्हाट अरेंजमेंट लुक लाइक, ठीक है? अब थोड़ा ध्यान से देखो, कैन आई नॉट राइट दिस r dash cos theta dash as you can say simply you just take an unit vector in this direction. So unit vector in this direction would be r cap. Unit vector समझते हो ना, मतलब इसका मैग्नीट्यूड बना जाता है. So this is r cap. डॉट प्रोडक्ट कर लो किसके साथ, r डैश के साथ. तो क्लियरली दिख रहा है कि जब मैं r डैश का प्रोजेक्शन लूंगा इस डायरेक्शन में, so it will be r dash cos theta dash. Is that clear? मतलब डॉट प्रोडक्ट लेने का मतलब क्या होता है, जिसके रेस्पेक्ट में डॉट प्रोडक्ट, जिसके साथ डॉट प्रोडक्ट लेते हो उस डायरेक्शन के अंदर तुम प्रोजेक्शन ही तो ले लेते हो. ये तो पढ़ाई हुआ ना बचपन में, इसमें कोई बड़ी बात नहीं बता रहा हूँ मैं. जैसे ए है और ये बी है और ये थीटा है, तो ये इसके अलॉन्ग प्रोजेक्शन लेना है, तो ए कॉस थीटा इसके अलॉन्ग प्रोजेक्शन होगा इन दिस डायरेक्शन. इज दैट क्लियर? सो इसके अलॉन्ग प्रोजेक्शन आर डैश cos theta dash ही तो होगा. So r dash cos theta dash is nothing but it is the projection of r dash vector in the direction of r cap. Is that clear? ये तो I think it is clear. I think this needs no explanation. So this is 1 upon 4 pi epsilon naught r square. So what I'm writing potential due to dipole, and this is this particular thing I'll write as r cap dot r vector dash, and then you have this rho r dash, and then you have d tau dash. Is that clear? And this is your integration. And instead of this, what I can do, because this is r cap, the integration depends on integration is over a prime coordinate. So I'll take this out. So I'll take this out. This is 1 upon 4 pi epsilon naught. This is r square, and then you have this r cap, and this particular quantity will be this here. There will be dot product r dash, rho r dash, and there would be d tau dash. Is that clear? Okay. Now just focus on this quantity. This quantity is called as your dipole moment. This quantity is called as your dipole moment. Is that clear? So this quantity is called as your dipole moment. So this was for so if I want to write it in a better way, so that so for continuous cases your dipole moment is given by r vector and then rho r vector d tau. Okay, इस तरीके से तुम बोलोगे. When you were very small kid and people used like standard 12, the similar expression, because for in 12th standard mostly systems are discrete or whatever, let's say जैसा भी था, so there you can write it as summation qi's into ri vector. So what are qi's? So ri's are the position vector for all these qi's, and let's say if they are distributed over, like if 4-point charges are on square and all those things. So basically what we need to know, if you want to find the dipole moment, all you need to know is your charge and the position vector of that charge. Just sum it up, and this qi you'll get the dipole moment. For the continuous case, you are going to find in this session this way. Is that clear? More appropriately, now potential potential due to dipole can be written as p vector, I think, dot r cap upon 4 pi epsilon naught. Is that clear? And you know that this will, if it is like r cap is direction, when this your p vector is direction, or yeah, theta, so this will become p cos theta upon 4 pi epsilon naught r square, which is the standard result which we have got also. Is that clear or not clear?
Yes, sir.
Okay. Okay. Now a few more things one needs to remember, and if I will write it, so it will be good enough. So I'll write it in like note only. I'm not going to derive it. चलो derive बाद में करेंगे इसको. पहले काम करते हैं. Let us first find. Let us first find dipole moments for some simple cases. So we'll see कुछ standard 12 की problem भी later on. but अभी के लिए थोड़ा सा because the level is high, तो level को high रख देते हैं. Let us first find the dipole moments for some simple cases. For some simple cases, is that clear? So let us first take it. Let us first take an example of सबसे easy पे लेते हैं. So this question was asked in I think JNU. So this question was asked in JNU exam. So it is a simple question, and the arrangement is as follows. Okay, so arrangement is as follows. So there is a charge minus q1 here. There is a charge minus q2 here, and there is a charge plus q1 here, and there is a charge क्या था यहाँ पे शायद q2 था. ठीक है, there is a charge q2 here. Okay, and this is at distance 0, b, 0. This is at a distance name at point 0, 0, 0, b, 0. This is at 0, 0, 0, and here you have a, 0, 0, and this is at a, b, 0. Okay, now we want to find what is the dipole moment, yeah, magnitude of dipole moment. What is the magnitude of the dipole moment for this configuration? So we want to find the magnitude of the dipole moment for this configuration, and then we'll see a few questions on multipole also. ठीक है, तो कैसे करेंगे? I told you, in order to find the magnitude of dipole moment, let us first find the dipole. So what would the dipole moment be like? The dipole moment would be summation qi's into ri's, isn't it? And what it will be? So it will be minus q1, and I will write 0 I cap plus 0 j cap plus 0 k cap. So forget about it. Plus this will be minus q2, and this will be ai cap. So I'll write ai cap here only. What this would be? This would be plus q2 b j cap, and the last one, this one would be q1. So this is minus q1, right? So this is plus q2. ठीक है, but this is minus q2. ठीक है, तो सही लिखा अभी तक. This will be ai cap plus bj cap. Is that clear? यहाँ तो कोई दिक्कत तो है ही नहीं. So your p vector, एक काम करते हैं, ai cap है ना, तो ai cap लिख लिया हम लोगों ने. So this will be q1 minus q2 times a, and then I'll write I cap plus j cap. I'll write q2 plus q1, and I will write bj cap. Is that clear or not clear?
Yes, sir.
Okay, so this is 1. So I'll write minus here, not the minus here. Okay. Now, if one wants to find what is magnitude of dipole moment, then it will be, I think, root over. This is something that is quite easy to see. This will be like q1 minus q2 per square, and then I can write a square, and then I can write q1 plus q2 per whole square. So in this, we are going to use some sort of advanced kind of thing. The advanced problem here, but otherwise, like mostly I'll use multiple expansions and all those things. Okay. So let us take a little bit difficult case, and that case is as if you can take another case where your so let us consider a ring of radius r as shown. So I've taken ring of radius r as shown. Okay, and let's say this distance is phi. Let's say this distance is phi, and the charge density over it is lambda naught cosine phi. Lambda naught cosine phi. Okay, we want to find the dipole moment due to this. Dipole moment for this configuration. Is that clear? So one needs to see that quadrupole moment would be 0. Sorry, quadrupole moment, monopole moment would be 0 because net charge is 0. can see lambda naught cos phi को अगर तो integrate करोगे on the entire ring from 0 to 2 pi, the total charge would come out as 0. Your total charge would come out as 0. Is that clear? So जब total charge ही 0 आ जाएगा, तो in general potential terms के अंदर जो monopole contribution है वो तो 0 आएगा, सिर्फ dipole contribution ही रहेगा, right? So we want to find right, चलो potential तो बात ही नहीं कर रहे, but we want to find the dipole moment for this configuration. How to find dipole moment? अगर स्टैंडर्ड 12th में होते और बच्चे को समझाना पड़ता तो बहुत लंबा प्रोसेस है इस पर्टिकुलर क्वेश्चन करने का, and that I would do because a few people in 12th class also are going to take some of the classes for JEE or something. अगर वहां पे मुझे क्वेश्चन समझाना होगा, there I will do a different thing. To explain a standard 12 child, what we need to do is we need to say कि ये वाला जो साइड होगा वो पॉजिटिव होगा, फोर्थ क्वाड्रेंट में पॉजिटिव होगा, and here there will be a negative, and then we need to make all sort of dipoles here इस तरीके से, and then we need to teach the student कि like कौन सा, समझ पा रहे हो मेरी बात? इस तरीके से करना पड़ेगा उनके लिए, है ना, उनके लिए ऐसा करना पड़ेगा, and then we need to show कि by symmetry only this side would survive. इस तरीके से करना पड़ेगा for the standard 12th going children. Okay, now because you are not a standard 12th kind of, not a standard 12th child, so what I'll do it in a manner that I've already prescribed. So what I'll do, I know what is my dipole moment. So my dipole moment is P vector is simply given by integral r vector dq. Now you'll say, what is that dq? So I'll take some small element, let's say because this is ring, so some small length element. So this is my phi, and let's say small d phi I'll make here. In this small element, I'll take r d phi. Okay, and this small element r d phi. So what would be charge contained here? So the charge contained would be lambda naught r cos phi and d phi. This is my dq. And what would be my r? R would be nothing, but it is equals to simply R only in magnitude. And what would be the best way to counter it? Just take some point, let's say x comma y. So I'll write my R vector as simply x I cap plus y j cap. Is that clear? And here I'll write lambda naught R, I'll write cos phi, and I'll write d phi. Is that clear? यहाँ तक किसी को बच्चे को परेशानी तो नहीं? And then I will write p vector is equal to integration from 0 to 2 pi. And what is x? So x I can write r cos phi I cap. What is y? I can write it as r sin phi j cap. And then I will write lambda naught r cos phi, and then I'll write it. Is that clear to you? ये चीज समझ में आ रही कहाँ गए सारे बच्चे? अल्पना समझ में आ रही, भरत समझ में आ रही बात?
Yes, sir.
So now understand that integral cos phi d phi over entire 0 to 2 pi would give you 0. This is quite easy to see. I mean, I'm leaving it as your homework. You divide by 2, multiply by 2. This would be sin 2 pi. This is quite easy to see. Only non-zero term would be in I cap direction. So integration from 0 to 2 pi, you'll get lambda naught r square, and then I'll write cos square phi, and this is d phi. And this is integration from 0 to 2 pi, and I'll write I cap also. This is integration from 0 to 2 pi, lambda naught r square, and then I will write 1 plus cos 2 phi upon 2, and this will be d phi, and this is I cap. So eventually, I will get my dipole moment vector in the direction of I cap, and that magnitude, whose magnitude is equal to lambda naught r square into pi I cap. Is that clear or not clear?
Yes, sir.
Okay. Okay. A similar case you can take for, let us say, like sphere and all those things. So let us now focus more on instead of dipole moment. I'll come back to all these questions later on because we need to see what is the effect of symmetry over dipole moments. That is one of the important topics from where your mostly your judged or your examination part is there. But right now, let us again move back to multiple expansion only. And let us do a question first to consolidate our learning of multiple expansion. And let us take a sphere. So let us consider a sphere. So let us consider a sphere centered at origin. Centered at origin, carrying a charge density which depends on r and theta in the manner I'll write it here. So r and theta in a manner I'll write it here. So this is k upon r square. And then I have this r. And then I have r minus 2r. And then I have the sine theta. And the capital R represents the radius of the sphere. So this is your radius of the sphere. And small r is a generalized distance. Okay. At some small r, you have this sort of from the origin this at small r, and theta you have this sort of volume charge distribution, and one needs to find what is an approximate potential. What is an approximate potential at a distance z? One needs to find. I want to find approximate potential at a far away distance on the z-axis at very far away distance along z-axis. Okay, so I'll give you a minute so that you can think about it, and then I'll start. Okay, so in multiple expansion, as I was teaching you, understand in general potential, here it is on the z-axis is given by potential due to monopole, then potential due to dipole, and potential due to quadrupole, so on and so forth. Okay, so what is the best strategy? The best strategy is to go step by step. So let us first find whether there would be some monopole contribution or not, because at very far of a distance, only leading term would survive. Okay, so what is the leading term? If let's say monopole contribution is non-zero, then the leading term would be governed by monopole potential. If this is non-zero and this is zero, then this would be the leading term. If both of them are zero, then obviously quadrupole term would dominate. Okay, and beyond that, I don't know. Given examination, they're not going to ask you. But let us do that. Okay. Let us first try to find what will be the monopole contribution to the potential. So monopole contribution is simply 1 upon 4 pi epsilon naught. And there was some r here, and integration rho r dash d tau dash, and this forms your total charge q. So let us first find what will be the total charge q. So if total charge q for this sphere capital R, so let us first find that. So that will be integration rho r dash d tau dash. Is that clear? And theta would vary from 0 to like r would vary from 0 to capital R. Okay, and theta would vary from 0 to, I'll write somewhere, theta would vary from 0 to pi, and on the complete circle your phi would vary, phi would vary from 0 to 2 pi, because your d tau dash in general for a sphere is written as r square sine theta r dash sine theta dash and d theta d phi and dr. तो एक काम करो, ये r dash हटाओ, अपन एक हम समझ तो सकते हैं ना, we can understand कि we want to find total charge due to this particular charge configuration inside the sphere. So total charge would be integral 0 to 2 pi, and then I'll write integration 0 to pi, and then I'll write 0 to capital R. And what is rho? कहाँ गया rho यार? Okay, so rho is, मेरे पास पढ़ा है मैंने क्वेश्चन कहाँ लिखा था, एक मिनट, हाँ ये रहा. So this is k upon capital R, and then I have this r square, and this I have capital R minus 2r sine theta, and then I'll write simply r square sine theta d phi and then dr. So this r square gets cancelled. Okay, this r square gets cancelled, and one can simply find your q integral since r is not dependent on theta and all those things. So I'll write integration from 0 to pi, and then you have the sine square theta d theta, d theta, and then integration 0 to 2 pi, and you have d phi here, and then integral k capital R from 0 to capital R, you have writing r minus 2r, and this is dr. Is that clear? Now, if you integrate it, the first term, this first term, if you integrate this first term, you'll get r square because r dr would give you r square minus r square by 2. So this will be r square, this will be 0. So overall total charge is 0. Since total charge is 0, so your monopole contribution would not exist. So monopole contribution to the potential would be 0. Is that clear? Is that clear?
Yes.
Okay. What will be the dipole contribution? So if you don't have this habit of forgetting, so I'll write instead of r dash only r, so that you don't मतलब समझ में तो आ जाएगा ना, ये r अलग है, ये r अलग है. Is that clear? तो ये अंदर वाले r, if I write r here inside the integration, it means variable inside, because r dash that is too clumsy to write here. So I'll write what is v dipole. So v dipole would be, I think, 1 upon 4 pi epsilon naught r square. Here I'll write an integral. I'll write r cos theta and rho. What was rho? It was, I think, again, I'll write it from here, k capital R upon r square, and then I will write capital R minus 2r, and then I will write sine theta, and then I will write r square sine theta d phi dr. This r square gets cancelled. This sine theta would go with this. D theta is there, cos theta is there. So again, I'll write v due to dipole would be integration 1 upon 4 pi epsilon naught r square. Let us find this integration. This integration would constitute, I think, capital R, k, and then you have r minus 2r, and then you have small r. This is dr from 0 to capital R. Is that clear? And then you have this integration from 0 to pi, and there would be a 2 pi, obviously, because of d phi integral. And this 0 to 2 pi, I'll do from sine square theta, cos theta, d theta. And one can clearly see that if I take sine theta as t, sine 0 is 0, sine pi is 0. So this will give you 0. So your the contribution to the dipole, contribution to the potential to the dipole is also coming out to be 0. Is that clear?
Yes, sir.
ठीक है. So it means that you are, इतना difficult नहीं है exam, but अगर आता है then you have to do till this portion. ठीक है. So we need to find what will be the potential to quadrupole, and that will be integration 3 cos square theta minus 1 divided by 2. 3 cos square theta minus 1 divided by 2, and then you have this k upon r, and then you have, I think, कहाँ गया ये? I think small r, and then you have capital R minus ये था ऐसा कुछ, and then you had the sine theta, and then you can write r square sine theta d phi dr, और आगे की तरफ आएगा 1 upon 4 pi epsilon naught r cube. Is that clear? ठीक है. और इसको तुम्हें पता करना ही पड़ेगा because I have lack of time. So इसको करो पता. So we'll meet tomorrow and I'll
R
start.
dash square.
मतलब obviously r, this entire thing would be r dash. No, अंदर वाली चीज r dash ही होगी, but मैं तुम्हें इसलिए कह रहा था, इससे कंफ्यूज मत होना.
मतलब सर ये 3 -1 के साथ R dash square वाली टर्म में आती है ना.
वापस बोलो, सॉरी, क्या कहना चाह रहे हो?
एक R dash.
ओके, दैट r square है ना, ये कहना चाह रहा हूं, राइट? एक r square.
हाँ जी सर.
सो इसको प्लीज तुम पता करो because this is a very big problem अभी के लिए. So this is something that I'm leaving it to you. इसको आराम से पता करो and then revert to me, and we'll start with this problem only tomorrow. Is that clear?
यही नॉन जीरो होगा सर शायद.
है ना, इसको करते हैं कल d theta d phi. Okay, so we'll meet tomorrow and we'll start with this problem. Okay?
यस सर. सर
हाँ जी.
सर वो जो एक प्रॉब्लम थी ना पी एन और पी एन एक्स वाली 0 to 1 इंटीग्रल वाली, जिसमें आपने एक वीडियो भी बनाया था, उसमें सर हमने डायरेक्ट वैल्यू करके आपने कुछ ऑप्शन एलिमिनेट किए थे डायरेक्ट वैल्यू रख के,
कौन सा वाला
मतलब
पॉइंट?
ऑर्डर इवन की डायरेक्ट वैल्यू रखी थी जिसमें सर ऐसे ऑप्शन थे m इज नॉट m
हाँ
माइनस
हाँ
वन
हाँ
इज
हाँ
m
हाँ हाँ हाँ,